Hi, this is Mrs. Slater, and today we're going to talk about radical expressions. So first I want to go over the certain parts of a radical expression, which the K is going to represent the index. The symbol is the radical sign. And the inside number is called the radicand. You will also need to know the difference between a principal square root, which is the positive square root, and a negative square root. For example, a principal square root is the non-negative square root, which is the positive. So when you are given a problem like square root of 16, I only want you to give me 4 for the answer. Same with square root of 121. 11 would be your only answer because I want the positive answer. Now a negative square root would be when the number, there's a negative sign in front of the radical symbol. Okay, so for example, if you had a negative square root of 16, then your answer is going to be negative 4. Or a negative square root of 121, then your answer would be a negative. Okay, now you may recall that you also had to use plus or minus in your answer. We end up using this later on in the chapter, but for right now we're going to use the principal square root or the negative square root. So I just want to just fast forward a little bit just so you know when you're supposed to use this. Okay, so in equations like x squared equals 49. Okay, in order to solve something like this, we would take the square root of both sides. And when you take the square root of something squared, you're automatically left with x. And when you take the square root of 49, this is where you're going to use the plus or minus 7 because both of those answers will work when you plug it in. For example, negative 7 squared, that equals 49, and just 7 squared is also 49. So we're going to need two answers when it comes to solving for x. So like I said, we are not going to have to use that early in the chapter, but later on, when we have to solve for x, we're going to be using the plus or minus sign. So now let's practice a couple examples. The first one, taking the square root of 1. Again, using the principal square root, the answer is 1. The next one is a negative square root, because the negative is on the outside, and the square root of 36 is 6. So those are both our answers for the first two. The next one, whenever you have a fraction, you may divide that separately. So you can get the square root of 81 and the square root of 100. And then anything that is a decimal like this, find the number that you know. For example, we know the square root of 64 is 8. Okay, and there are 4 decimal places after that first decimal place, so there's 4 spots. So that means our answer is going to use 2 of them. It's always going to be half of what the original is. Also a negative square root, so then that is going to be your answer. In class, I'll show you how to use your calculator as well. Okay, and then the next 3 are very simple, but yet very tricky, so you got to be careful. This one, the first one, if we're using the perfect square of 9, it's going to be 3. Okay, this is the negative square root, so you're going to have a negative 3. And the last one, anytime there's a negative on the inside, that is considered an imaginary number. So at this point in the chapter, we're just going to say no real solution. Negative on the inside is what I'd like you to write for the notes. Okay, so no real solution would be your answer on anything that has a negative on the inside. There are three rules that I'd like to cover in this section. Rule number one is for any real number, a, square root of a squared equals the absolute value of a. So keep that in mind for a lot of the answers. The principal square root of a squared is the absolute value of a. So you're always going to have a positive answer. So when you're looking at the first example, there are two ways that you could solve it. So let's go ahead and look at those two ways. You could look at it as, I'm going to evaluate everything inside, which a negative 9 times negative 9 is positive 81, and you get an answer of 9. Or, using the rule above, you can solve, because anything squared, so there's the symbol you should look for. This is your square root, anything squared, so whatever's in that spot, you take the absolute value of that answer, or whatever's inside, to get your answer. Okay, so in either case, you're going to get 9. Now, for the more difficult problems, the rule is going to be more obvious. This one, we're going to have to factor first, and you get x plus 5 squared. Okay, now once again, we are with a square root squared, so that means anything on the inside has to be the absolute value of it. And that is where we're going to have to stop, because we do not know what the value of x. So that is your final answer, absolute value of x plus 5. And then the next one, I'm going to simplify what is inside by knowing what the square root of 49 is and the square root of y squared. So all of that, we could say, is squared. And again, square root of something squared, look at that. We take the absolute value of the value that's inside. Now what we do know is that the absolute value of 7 is 7. So I'm going to take that out of the absolute value signs. But what we do not know is the value of y. So we're going to have to leave that inside. The next four I want you to try on your own, and we will go over those tomorrow in class. So have them all complete and ready to be discussed. The second rule deals with perfect cubes. Anything that is a perfect cube of something cubed is just going to be that letter. So, for example, on the first one, let's think about what this will mean. The answer, I'll go ahead and tell you, is -1. Okay, so any value that's in the cube root that it is something cubed is going to be itself. Because -1 times -1 times -1, there's our 3 times. When you multiply that together, you get -1. So that's why the cube root of that is going to be -1. The next one is the perfect cube of -125. And if you're looking at this one, we know that we've got to think of what multiplies 3 times to give you 125. And that's going to be -5. So then the answer to this would be -5. Okay, just like the previous rule, this you can split up into 2. Cube root of 8, cube root of 27, and that's going to be 2 over 3. So you can have that as your answer. Now keep in mind the perfect cubes are over here, so you may have to refer to those. These are the most common used. The cube root of 1 is 1. The cube root of 8, I should start over here. Cube root of that is 2. Cube root of this is 1, and so on. This is the cube root, the cube root of 64 is 4. Cube root of 125 is 5. So you'll see those a lot. Okay, and then the next one, if we take this and cube root each of them, so now you have the cube root of something cubed, so the answer is just going to be what is inside. So in this case, it's just 4x. We do not have to have any absolute values for cube roots. And the next 3 I would like you to do on your own, and then we will go over those in class. the 64 and the 27 have already been talked about, but the last one, this 343, I want to show you how you can do this on the calculator. So go ahead and push pause and get your calculator out. Okay, so if we're going to find the cube root of something, you push math, and then number 4, you see how it says cube root, we're going to push that or scroll down to it, and then you can just put in 343 and push enter. Okay, and so you end up with 7, and you also could do a negative as well. So I'm going to put in negative 343, and I get an answer of negative 7. Okay, so if I'm going to answer this, the cube root of negative 343 and the cube root of 64, I would find each one of those. So I already know this is negative 7, and then I'll let you figure out the rest. Okay, so now let's go on to the third rule, which is to separate the even roots and the odd roots. So if you see, and what I mean by roots is index, of course, that little number that's on the outside of the radicand, or the radical sign. So you're looking at the odd index, you're looking at the even index. There's going to be absolute values, and here you don't have to worry about it. So in these examples, let's get the calculator out again. And you go back to math and fourth root. Even if you notice it's not there, so let's second quit. We got to put what index we want in the calculator first and then go into math. Number 5 is open for anything. So some of your calculators will automatically put the 4 in like a little index. Others may not, but that's okay. It'll just say 4 and then it'll say x root. And if you have a question on that, please ask in class. But here we have the fourth root of 81, so I know the answer is 3. This one is a negative square root, so all that means is we're going to have a negative on the outside, and this is the exact same thing we just did, so that's going to be negative 3. For the next one, anytime we have an even index, and you have this negative on the inside, that is bad news. This is the imaginary number, so there's going to be no real solution. Now I also want to point out something on your calculator that happens. And if I went ahead and forgot about that rule and I did math, sorry about that, if I did 4 and then math, I picked number 5, and then I put my negative 81 inside, look what happens. You're going to get a non-real answer. So your calculator will tell you if you forget that rule. Okay, so let's go ahead and get the next one. No real solution is the answer here. And here we have a mix of a couple things. We have the fourth root of 16 times the fourth root of x minus 2 to the fourth. Lots of things going on here. So when you find, push pause and find the fourth root of 16, and you should get 2. And the fourth root of anything to the fourth, again, I want to clarify that, is going to be the x minus 2. Now this is an even root, therefore there are absolute value signs on the x minus 2. Okay, and then the last one on this, I want you to look at, push pause, get the calculator out, see what you can come up with there. And we have the fourth root of 256, which is going to be helpful with the calculator, and the other two you're not going to be able to do because there is a variable. But they're all to the fourth root, all multiplication, so we can spread them out. So by now you have found that the fourth root of 256 is 4, and this is C, and this is D. And because there is an absolute value, the C and D, we do not know what it is, so the absolute value will guarantee it, that it's going to be a positive. So there, just a little cleaned up. And that's going to be your final answer. Okay, with the next 2 slides, I would like you to go ahead and practice. This is fifth root. So again, you're going to use the fifth root, put the 5 in first, and then go to math, and you'll be able to do some of them. And then I'm just going to let you experiment with this page and the next. See you in class tomorrow.